Vapor barriers and the movement of moisture. In residential and commercial construction, we use vapor barriers to control the flow of moisture into the building's envelope. Moisture comes in a couple of different forms: humidity or liquid. When a home is built new or an existing home has an addition put on it, we use Tyvek, officially known as house wrap. This material allows some moisture or vapor flow while stopping both liquid water and air. Different grades of house wrap have different properties. When discussing vapor barriers, we also call it drainage planes, the measure of water vapor permeability is called the perm. As mentioned earlier in the program, if a material has one perm, then it allows transmission of 1 grain or gram of water vapor per square foot of area per hour per inch of mercury-based differential. So let me repeat that. It allows a transmission of 1 grain or gram of water vapor per square foot of area per hour per 1 inch of mercury pressure differential. Depending on the climate zone, different levels of vapor barriers are used. Some areas require low perm vapor barriers and other areas require high perm vapor barriers. There's 3 things you should know about vapor impermeable vapor barriers. There's Class 1 and 2. Class 1 is 0.1 perms or less. Class 2 are 1.0 perms or less. And then there's rubber membrane, or polyethylene film, glass sheet metal, foil face sheathings, or aluminum foil. Let's talk about semi-permeable vapor retarders. They're considered Class 3, which means 10 perms or less. And there's exterior grade plywood, asphalt impregnated building material, many latex-based paints, as well as paper, or fiberglass bad insulation. Vapor permeable or breathable. That would mean more than 10 perms and unpainted gypsum board, unfaced fiberglass, and most house wraps. There's 3 different ways that moisture is transported through building materials, and there's 3 methods. Capillary action, the surface must be wet. Air transported moisture, where small particles of water are carried by the air. It usually occurs under pressure. This method is usually more significant than vapor diffusion, and vapor diffusion, which is part of the second law of thermodynamics. Moisture will flow across a concentration gradient as well as a heat gradient. More flows to less. Proper moisture control usually requires both an air barrier as well as a vapor barrier. Uncontrolled air infiltration into buildings due to inadequate air barriers can lead to significant damage. Let's look at vapor barrier requirements for different climate zones. In a cold climate, you want to make sure that it's as difficult as possible for building materials to get wet from the interior. We want to let the building dry by installing vapor permeable materials on the exterior. And install air and vapor barriers on the interior building walls. Hot and humid climates. Install air and vapor barriers on the exterior building walls. We want to make it as difficult as possible for building materials to get wet from the exterior. We want to let the building materials dry to the interior. And finally, interior spaces must be maintained at a slight positive pressure with dehumidification. Interior spaces must be kept below 50% humidity. In hot and humid climates, this requires both dehumidification and the use of ventilation to create a positive pressure within the conditioned space so as to prevent infiltration of humid outside air. In a mixed or complex climate, you want to use permeable or semi-permeable materials on interior and exterior. This requires both air pressure control as well as interior humidity control. Install vapor barriers in the approximate middle of the wall with insulated sheathing on the exterior. The air barrier can be either towards the interior or the exterior. Air pressure and humidity control must be utilized. Humidity flows outward in the cold, dry months and must be stopped at the interior walls. Humidity flows inward in the warm summer months and must be stopped at the exterior or at the sheathing. With wood frame homes, which are very common in the US, wood grows thicker and with increased moisture, not longer. It also shrinks along its width, not its length. When dealing with manufactured wood products, try to compensate for this by using cross-graining and fiber orientation or resins and waterproofing materials. They tend to expand in all directions rather than just one. This expansion and contraction will cause separation and allow for water and/or water vapor to enter through the gaps. Let's review some common moisture levels found in wood. Working from the bottom up, manufactured wood has a 3 to 4% moisture level. If it's kiln-dried lumber, then it's 5 to 6%. Air-dried lumber is between 20 and 30%. And green lumber has 45 to 50%. During the construction process, most builders do not take time to cover their lumber or the framed homes. So they're really not protected from the elements. A wood frame home can absorb a great deal of moisture during the construction process. For example, wood fiber saturation is easily 25 to 30% by weight. If you have natural occurring wood rot and mold spores in the wood, they will activate when the moisture content raises above the 19 to 20% range. In order to prevent mold amplification, which is the accelerated deterioration of materials with mold growth, the moisture content must be kept below 16%. Even with low indoor humidity levels, cold weather causes condensation from exterior door hinges, wood frames, inside walls with sufficient vapor barriers. This will increase moisture content in small areas. Exterior moisture can be from rain, but it also comes from humidity. While most people can understand that the house must be protected from rain, they can easily overlook the real mechanism of moisture penetration into the house. Water, in the form of water vapor, has a much greater effect on the house than does liquid water. You may not know this, but rain patterns do differ each year and according to region. Rain affects the house even before it is built, as well as after. Let's review rules for water movement. Water vapor travels from areas of high pressure to areas of low pressure. Water vapor travels from warm areas to cold areas driven by heat. Water always runs downhill. Water vapor travels from wetter areas to drier areas driven by what we call capillary action. The long and short of it is this: water can move in many directions through the building's exterior envelope and inside the home as well. The house must be able to shed water from the roof to the footing. The roof is not waterproof but water resistant. It's designed to take the rainwater away from the house. The roof must work with the gutters, downspouts, as well as the exterior wall covering. These different components must be matched in order to work together properly. The roof to the exterior wall must allow water to properly shed, as well as allow proper ventilation for the attic area and provide a proper seal against water intrusion into the exterior wall covering. These details are often lost between the work of the framers, roofers, as well as the masons. If not properly coordinated, a latent defect is created. Signs of deterioration on a masonry or brick structure includes deteriorating mortar joints and signs of efflorescence. You might also see water wicking up the masonry wall, especially if it's in contact at grade level. Efflorescence is the white chalky powder that you might find on the surface of a brick or concrete wall. It might be cosmetic, such as when concrete is curing in its first year, or it could be an indication of moisture intrusion that could lead to major structural or indoor air quality issues. Efflorescence is the dissolved salts deposited on the surface of any porous material, such as concrete or brick. Essentially, it's what's visible after the evaporation of the water in which it was transported. The moisture that creates efflorescence often comes from groundwater, but it could also come from rainwater too. Efflorescence alone does not pose a major problem, but it can be an indication of moisture intrusion. Please note, building materials such as concrete, brick, stone, or wood are considered porous materials. When you have porous materials, they can absorb or wick water by a process known as capillary action. As water moves through the porous material, salts can be drawn with it. You should know that if you're using a thermal imaging camera and there's spalling taking place, that there could be a temperature difference in that area. It is most likely that the spalling area is retaining moisture. It is not warm air coming through the brick. If you ever question whether something's wet or not, it's always best to use another tool like your moisture meter in order to determine whether it really is wet. If you have siding such as metal, wood, or vinyl, it does not provide an additional air barrier. If you have two-coat stucco, usually applied over a brick wall, it allows for a greater hydric buffer, but unless there's sufficient drying time allowed, moisture is retained in the brick. If you have three-coat stucco, this does add a waterproof layer of sheathing paper. However, this system has a lower hydric buffer capacity, but it makes up for it in the added waterproof layer. The type of waterproofing you use is important, such as EIFS systems. They add an insulation layer, but they're very susceptible to damage if not flashed or sealed properly. With EIFS, the quality of the installation is always the key. If not properly installed, the foam can become a huge sponge. Because of the foundation's porous nature, moisture can also wick up from the ground. If the downspout is near the foundation, water is wicking up from the foundation wall. Colder temperatures are on the exterior. The building must be able to shed water and manage water away from the foundation and structure. A simple thing like diverting downspouts is essential. Lots of times there's missing splash blocks. So let's look at some of the most common water penetration points at a home. The roof ridges, gable vents, dormer flashing, the chimney, around window flashing, header flashing at the windows as well as doors, windowsills, deck ledger flashing, the bottom of door jambs, door treads, light fixtures, roof-to-wall intersections, anywhere siding contacts the ground, roof vents, site drainage, roof attachments, and more. Since moisture is also dissolved in air into water vapor, moisture also moves with air movement. The effects of wind on the exterior of the house are synergistic with the effects of moisture intrusion. They work in tandem with each other. Wind can drive water intrusion, but it can also have a drying effect if the relative humidity is different. Moist air can wet a house, and dry air can dry the house. But all of these effects interact with the hydric buffer capacity of the house. So how does the added pressure of the wind affect moisture intrusion? When you're performing an energy audit, always pay attention and look at all the factors involved. Wind will produce a positive pressure on one side and a negative pressure on the opposite side. You need to consider these effects if the house has a complex shape. If there's a windstorm, there's an imbalance of interior and exterior pressures. The wind pressure effects on a house must also be considered with regard to neighboring structures.